Welcome to the video presentation about stoichiometry. Today, we're going to discuss this big word that describes a simple idea. Well then, let's begin. What is stoichiometry? Stoichiometry is one of the most important topics in chemistry. It involves the use of chemical formulas, mole calculations, and chemical equations. It is a relationship of quantities, mass of a substance or volume of a gas, and a chemical exchange according to the balanced chemical equation. Stoichiometry is also essential in industry. There, it is used to do cost and analysis for manufacturing chemicals. In fact, manufacturing processes are financed according to the cost of reactants, and the values of products are determined by stoichiometric calculations.
The law of combining volumes. Combining volumes is the principle volume of gases that combine in a chemical reaction at the same temperature and pressure are in the ratio of small whole numbers. In one of his experiments, Gay-Lussac studied the reaction of hydrogen and chlorine and found out that one volume of hydrogen gas combined with gas of chlorine give 2 volumes of hydrogen chloride gas. Avogadro's law claims that equal number of hydrogen molecules and chlorine molecule would have equal volumes. In another experiment, Gay-Lussac studied the reaction of hydrogen and oxygen. He found out that 2 volumes of hydrogen gas combined with 1 volume of oxygen gas. In this case, the gases combine in the small whole number ratio of 2:1. Example exercises. After balancing the following equation for the combination of propane and oxygen, interpret the coefficient in terms of moles and liters. We can supply the following coefficients to obtain a balanced chemical equation. The coefficients in the equation 1:5:3:4 indicate the ratio of moles as well as the molecules.
And now, let's move on to the types of stoichiometry. Mole-to-mole stoichiometry. A type of calculation that relates the most of two substances participating in a balanced chemical equation. The coefficients in the chemical reaction also indicate the ratio of moles of reactants and products. The coefficients in the chemical reaction also indicate the ratio of moles of reactants and products. Consider the complete combustion of natural gas. Methane, CH4, reacts with oxygen to give off carbon dioxide and water. The coefficients indicate that 1 mole of methane reacts with 2 mole of oxygen. Suppose we wanted to find out how many moles of oxygen reacts with 2.25 moles of CH4, we can set up the problem as follows. We could also calculate the moles of carbon dioxide produced from the reaction. In the balanced chemical equation, we have 1 mole of methane yields 1 mole of carbon dioxide. Applying the unit factor, we have
Mass-to-mass stoichiometry is so named because an unknown mass of a substance is calculated from a given mass of a reactant or product in a chemical equation. The process for solving mass-to-mass stoichiometry problem is outlined as mass of given to moles of given to moles of unknown to the mass of unknown. For example, consider the high temperature reduction of 14.4 gram iron oxide to elemental iron with aluminum metal. To calculate the mass of aluminum necessary for the reaction requires 3 steps. calculate the moles of iron 2 oxide. Since the molar mass of iron oxide is 71.80 gram per mole, then convert the number of moles to moles of aluminum by applying the coefficient from the balanced chemical equation. After that, use the molar mass of aluminum as a unit factor to obtain mass of aluminum reacting with 14.4 grams of iron oxide. The solution to the problem can be shown as
Mass to volume stoichiometry. Mass to volume stoichiometry problem. We first convert the mass of a substance to moles. We then convert the moles of a given substance to moles of an unknown substance using the coefficients of the valence equations. Finally, we multiply the moles of the unknown gaseous substance by the molar volume to obtain the volume in liters. We must always begin with the balanced chemical equation. After balancing the equation, proceed as follows. Convert the relevant given mass of substance into moles using molar mass as a unit factor. Then, convert the number of moles of given substance into moles of unknown substance using the coefficients in the balanced chemical equation. Calculate the volume of gas using 2.4 liter per mole at SDP. It is also possible to perform the reverse calculation, that is, we can find a mass of unknown substance given the volume of gas. For example, the reaction of 0.165 grams of aluminum metal reacts with dilute hydrochloric acid, forming aqueous AlCl3 and hydrogen gas. Find the volume of hydrogen at SDP. Let's calculate the volume